All right, let's dive in. Today, we're going to pull back the curtain on something that pretty much runs our entire digital lives, the Wide Area Network, or WAN for short. I mean, have you ever really stopped to think about it? You're on a video call, maybe you're in one city, your coworker's in another. Heck, they could be on the other side of the planet. And yet, it just works. You see them, you hear them, almost in real time. Well, that's not magic, my friends. That's the power of a WAN.
So here's what we've got on top. We're going to start small with the network you already know, your LAN. Then we'll talk about the big challenge, distance. We'll open up the toolbox of technologies that make WANs possible, see how they've evolved into the modern internet-based WANs we use today, and finally, we'll see just how much these things really do power our world.
Okay, so Section 1. Let's start with something we all know and love, the network that's probably right under your roof.
So take a look at this. This is your classic home or office setup, right? You've got your computers, your phones, maybe a printer, all hooked up, probably with some cables. It's like its own little self-contained island of connectivity. And here's the key takeaway for a LAN, or local area network. It's all about being under the same administrative control. That just means one person or one IT team is in charge of the whole shebang. The security, the connections, everything. It's your private little digital kingdom. But what happens when you need to connect your kingdom to another one, maybe 1,000 miles away? And that right there is the big challenge. I mean, you can't exactly run an Ethernet cable from San Francisco to Tokyo, right? You need something else entirely to bridge those huge geographical gaps. And that's where the wide area network, the WAN, comes into play. You see, a WAN is basically a network of networks. It's not connecting your laptop to your printer. No, it's connecting your entire office network in one city to another entire office network in another city. And to do that, it usually has to rent space on the big communication lines owned by telecom companies. This slide really breaks it down nicely. On the one hand, you have the LAN. Scope, small, a single office, a single building. You own it, you control it. Simple. Then you have the WAN. Scope, huge. We're talking cities, countries, continents. And because you can't own all that infrastructure, you have to use public or leased lines from carriers. So the big idea is LANs connect devices, but WANs connect LANs. So how did we even get here? How did we build these incredible long-distance networks in the first place? Well, let's take a little trip back in time and look at some of the key pieces of tech. First up, we have this old timer called X25. Now, you gotta remember, back in the day, phone lines were, well, they were terrible. They were noisy, unreliable, analog things. So X25 was built for survival. It was super, super cautious, with tons of error checking to make sure every piece of data made it through the muck. The trade-off? It was slow. We're talking 64 kilobits per second. Think really old school dial-up speeds. But hey, it was tough, and back then, tough was what you needed. And this diagram shows you kind of how it worked. Your gear, the data terminal equipment, or DTE, which is just a fancy name for your computer, connects to the network's equipment, like a modem. From there, your data gets sent into this big network cloud. X25's job was to be the traffic cop inside that cloud, carefully checking and guiding your data packets until they safely reach the other side. Okay, so as the phone lines got better and went digital, all that heavy-duty error checking in X25 started to feel like, well, overkill. It was slowing things down for no reason. So along came Frame Relay. It was designed to trust the network a lot more, and it stripped out a bunch of that old-school error checking. And the result? Way less overhead, which meant much, much higher speeds. This was a huge leap forward. And then there was ATM, or Asynchronous Transfer Mode. And this thing was a completely different beast. You see, while other technologies sent data in packets of all different sizes, ATM did something radical. It chopped up everything, voice, video, you name it, into these tiny identical 53-byte packages called cells. Why? Because when every piece of data is the exact same size, you can manage the flow with incredible precision. This was perfect for handling things like voice and video without them getting all choppy. This image shows you the other secret to ATM's success, the virtual circuit. Before it sent a single cell of your data, the network would set up a dedicated, pre-planned path from the start point to the end point. Then all those little 53-byte cells would just zoom down that same path, like cars on their own private highway. This guaranteed they'd arrive in the right order and super fast, which is absolutely critical for real-time stuff, like a phone call. Okay, so that brings us to today. Let's be honest, you don't hear people talking about Frame Relay or ATM much anymore, right? So what does a modern WAN actually look like?
Well, for most of us, it boils down to one thing: the internet.
And that's where the VPN, the virtual private network, comes in. A VPN is so clever because it gives you the best of both worlds. It uses the public internet, which is everywhere and relatively cheap, but it creates your own private, secure, encrypted tunnel right through the middle of it. Think of it like having your own armored, invisible lane on the public information superhighway.
And this picture right here, this is the modern WAN in a nutshell. You've got someone working from home. They connect to their regular internet, but then the VPN software fires up and builds that secure, encrypted tunnel straight to the company's main office network. As far as their computer's concerned, it's like they're sitting right there at their desk in the office, with safe and secure access to all the files and servers they need.
All right, so let's zoom out for a second. We've talked about the tech, but what's the real-world impact? Why does all of this stuff matter so much?
Well, the benefits are just massive. Modern WANs, and especially VPNs, let companies connect their teams no matter where they are in the world and do it securely without spending a fortune on private lines. This is the technology that literally makes remote and hybrid work possible. It boosts productivity for global teams, simplifies the network for IT folks. I mean, it's what opens the door to global business for everyone.
And really, it goes so far beyond just business. That online class you're taking with a professor halfway around the world, the e-commerce site where you can buy something from another country, the social media that connects you to friends and family everywhere. Yep, it all relies on the fundamental principles of wide area networking that we've been talking about.
It is, without a doubt, the backbone of our interconnected world, which, leaves us with a pretty big question to think about. As our demand for more data delivered faster and more securely than ever before continues to explode, what's the next generation of WANs going to look like? What comes next? Thanks so much for joining me.